Hello friend, I'm Samadhi back to a new tutorial video regarding IS456-2000. In this video, we'll talk about some clauses about the limit state method. So if you want to know about the limit state method code provision, then that video is for you. Otherwise, you can skip it. And if in case you missed the last this IS456 series or playlist, so you find there is I button, so just go out and check out the playlist of IS456. So without further delay, let's get started. So we start from the 35 number clauses. We completed the last 34 clauses in our last video. So this is section 5, structural design for limit state method. So this section is very much important from your MCQ point of view and as well as conceptual, and if you appear from gate examination, so definitely check this section very carefully. So without further delay, jump to 35.1 clause in general. In this method, design based on limit state concept. The structure shall be designed to withstand safety. So in WSM method, there is no kind of provisioning of the safety, but here we talk about first step for safety. All loads liable to act on it throughout its life. Its life means structural life. Suppose you build a structure. Okay. So say it is life is 50 years. So its life means structure life. It shall also satisfy the serviceable requirement. In WSM there is no serviceable मतलब होता है the structure, is it for serviceable, yes or no? If yes, then definitely serviceable, such as limitation of deflection and cracking. So one structure is serviceable or not, we find out in two parameters. One is deflection, another is crack. The acceptable limit for safety and serviceability requirement before failure is called limit state. So if someone asks you about limit state, so you just quoted this line. The acceptable limit of the safety and serviceability requirements before failure is called is limit state. So I hope the definition is clear. Now we talk about the aim. The aim of design to achieve acceptable probability that the structure will not become unfit for the use for which it is intended. So aim is the design to achieve acceptable probabilities that the structure will not become unfit. So will not become unfit, that means if you remember the partial safety factor, what is this? We take, if you remember, there is some graph when I talk about further, you will understand. So will not become unfit matlab means that will not unfit. Look, it means that safe against max load or moment for the use of which is intended, that will not reach a limit state, that will not reach the limit state. Which limit? So the limit is your the moment of resistance, say 100 kilonewton meter. So that is your limit. If more than this, then fail. If less than this, safe. So what is this? This is basically one boundary or limit. So that is your limit state. Hope that is clear. If not clear, definitely do comment in comment section. 35.1.1. All relevant limit states shall be considered in design to ensure adequate degree of safety. WSM, we talk about safety not in conscious mode. As limit state, we talk about the safety. The structure shall be designed on the basis of most critical limit state shall be checked for other limit state. Actual uh, limit state method has the five or four aspect. One is limit state of collapsibility, serviceability. We'll talk about that. So that is why they are saying other limit state. It's not like that limit state method we do the design and done. It's not like that. Ensuring above objective, the design should be based on characteristic value for material. Material that means one is your concrete, another is iron. That is Fe. So characteristic load that is the your M25, that is Fe415, Fe500, M30, so on, so on. So that is characteristic value. I hope you know about the what is the characteristic strength. If you don't know, then definitely do comment, or you can check the previous video where I talk about the what do you mean by characteristic strength, and probably next week we'll talk about the characteristic strength. Characteristic value for material strength and applied load. When take into account the variation in the material strength in the load to be supported, the characteristic value should be based on statistical data if available. Statistical data if available, that is, I give you an example. Target strength. If target strength equal to FCK plus K into S, that S is standard deviation. So standard deviation we find, how the standard deviation we find, so it's come from the mean median mode. How to come, there is a lots of sample, 1 2 30 number of sample, you take the mean median, then you find is into that. Whole method is known as your statistical data. Statistical data is available. Where such data are not available, they should be based on experience. Mostly this statistical data are available. Experience is too much risky. The design value are derived from the characteristic value through the use of partial safety factor. So one thing important is that the design value, that means design strength is characteristic strength and use a partial safety factor. Your design strength, suppose your characteristic compressive strength is 30, okay, and partial safety factor say 1.5, then your design strength FD, design strength would be 30 into 1.5. In the absence of special consideration, this factor should have value given 36 according to material, the type of loading and the limit state being considered. Now we talk about the limit state of collapse. This is the one type of limit state of collapse. One type of limit state. So we design according to the collapsible limit state of collapse. The limit state of collapse structure, part of the structure could be from the rupture of one more critical section, from the buckling due to elastic or plastic instability or overturning. So let's understand word by word. The limit state of collapse of structure or part of the structure could be accessed from the rupture. Rupture means crack. Where should I write? Rupture, that means crack. Crack due to more critical section. When you start the design, we talk about the critical section. Critical section, as simple as that, where bending moment is maximum. That is your critical section. Roughly, you can assume that. Then critical section, why? Either buckling or elastic or in plastic stability or overturning. The resistance to bending, shear, torsion, axial load at every section shall not be less than the appropriate value. That is why suppose this is your beam and this is your UDL, and the bending moment should be like this. So we always take this maximum value. If we take the maximum value, then this value is safe here, this value is safe here. Every point these value are very safe. Okay. Section should not less than appropriate value at the section produced by the probable most unfavorable combination of load on the structure using the partial safety factor. Okay, they talk about the unfavorable combination. Combination means when we design, generally what we add the dead load plus live load into one point. But this is a one combination. There is another one 5 to 6 combination. So in 5 to 6 combination, you find a maximum value. That should be your design value. Now we talk about the second is limit state of serviceability. So collapse is done. Now talk about the serviceability. The first we talk about the cracking. The cracking of concrete should not adversely affect the appearance of durability of structure. The acceptable limit of cracking would vary with the type of structure and environment. Environment, that means type of exposure condition: mild, medium, severe, very severe, moderate, where specific attention is required to limits of design crack with a particular value. The crack width calculation may be done using the formula. Generally, we need not this formula. The practical objective of calculating crack width is merely to give guidance to the designer in making the appropriate structural arrangement and in avoiding gross error in design. So that means you can, but there is no mandatory, and that is not mandatory. That is why they are saying again the practical objective of calculating crack width is merely to give guidance to the designer in making appropriate structure arrangement and avoiding gross error in design. Remember, there is a deflection control clause where simple support is 10, cantilever is 7, continuous is 20. There is some limit, deflection limit. Anyway, then we talk about how which might result in concentration or excess width of etc. The surface width of the crack should not in general exceed 0.3 mm. Remember this value. In member where cracking is not harmful and does not have any serious adverse effect upon the preservation of reinforcing steel nor upon the durability of the structure. In member where cracking in the tensile zone is harmful, either because they are exposed to the effect of the weather or continuously exposed to moisture or in contact soil or groundwater. Talk about the foundation. The upper limits should be 0.2 mm. So there is not 0.3 mm. 0.3 mm is the normal value. 0.2 value is some special value for where chance of expose in the weather or expose in the moisture content. Okay. In severe category, this 0.2 mm is 0.1 mm. So 0.1 for severe, 0.2 is your exposed to weather or moisture. 0.3 is normal. Other limited methods, structure designed for unusual or special functions shall comply with any relevant additional limit state consideration appropriate to the structure. So yeah, that is the very slow video, short video regarding safety and serviceability requirement as per LSM. Next video will start from the characteristic, design value and partial safety factor. So I hope in these whole 35 number clauses you have no doubt. If you have doubt, definitely do comment in comment section. I'll definitely get back to you, and until and see you next video. Until bye bye, take care, and definitely thank you for watching this video.